Hello everyone. Now in today's tutorial I will teach you the rhombus theorem. Okay, now let's see the statement here. Prove vectorically that the diagonals of rhombus are bisected with each other. Okay, bisected with each other at 90 degree. Okay, now first let's see what is rhombus. Rhombus means what? It is a parallelogram having all sides are equal. Yeah, if a parallelogram having all sides are equal, then it is called rhombus. Okay, and here the figure ABCD is a rhombus. Rhombus means their all sides are equal. AB, BC, CD and AD, all sides are given. Okay, and here AC and BD are diagonals. Their diagonals, and we need to prove is their diagonals are bisected with each other at 90 degree. Okay, now let's see the given here. Given is simply ABCD is a rhombus. This ABCD is a rhombus in which this AC and BD are diagonals. Okay, and as it is a rhombus, so all sides are equal, so we can write AB equals to BC equals to DC equals to AD. These all magnitudes, the sides are equal. Okay, now we need to prove. Prove is what? The diagonals AC and BD are bisected with each other at 90 degree. Okay, here it seems like we have to prove two things here. One is bisected with each other, and another is what? 90 degree. Okay, now bisected with each other, we no need to prove, we can directly write. Why? This ABCD is a rhombus and rhombus is a parallelogram, and we have already proved the theorem. The diagonals of parallelogram are bisected with each other. So in one number we can write it is obvious that AC and BD are bisected with each other because it is a parallelogram. Okay, so let me write one number first. One number, the diagonals AC and BD are bisected with each other. The reason is what? Being parallelogram. Being what? Parallelogram. Okay. Now our main focus is on 90 degree. They are bisected with each other at 90 degree. Now let's prove 90 degree. And before that, let's take some idea in vector when the two vectors are 90 degree or perpendicular. Now let us suppose there is one vector A and there is another vector B. In which conditions these two vectors are perpendicular? Everyone knows, yeah, that is if their dot product is 0. If their dot product is 0, then we can say these two vectors are always perpendicular. So here we need to prove is AC and BD are perpendicular. So for that, if you are able to show this AC and BD, their dot product is 0, then you can say they are perpendicular. Okay, so let's try to prove their dot product 0. Now for this, first let's find AC vector. Okay, AC vector. Then after BD vector. After finding them, let's find their dot product. Okay. Now in two number. See here. For finding AC vector, there is two triangles ACD, ACB. Either of the triangle you can take. Yeah, you can take either of the triangle, no problem. Okay, so I'm taking here is ACD, here ACD. In ACD, AC vector equals to AD vector plus DC vector. Okay, using the triangular law of vector addition. So in this case, AC vector equals to what? AD vector plus DC vector. Okay, AC equals to AD plus DC. Yeah, your starting point is A, so start with A and ending is C, and the last point is C. So let me write here, in triangle ACD, using triangular law of vector addition, AC vector equals to AD vector plus DC vector. Okay, now 3 number. Similarly, now we found here AC. Now let's find VD. For finding BD, also there is two triangle. One is ABD and there is BCD. Either of the triangle you can take, no problem. So I'm taking here is ABD. This is ABD. Here also let's use the triangular law of vector addition. So in this case BD vector. Now see, this is BD vector. So what is BD vector? BD vector equals to BA plus AD. So we can write this is BD equals to BA plus AD. Okay. So let me write in 3 number. In triangle ABD, using triangular law of vector addition, here is BD vector equals to BA plus AD. Okay, BA plus AD. Now let's take their dot product. Now before that, first let me simplify it. Now this BA can be replaced by minus AV, and this is plus AD. Yeah, this is what AV vector equals to minus BA vector, or you can write BA vector. BA vector equals to minus AV vector. So here equals to, you just arrange them. This is AD minus AV. Now look at here. This is AD. Here is also AD. Now let's take this AV and DC. Here is AB and DC. They are equal in magnitude because this is parallelogram. Opposite sides are equal, and they are parallel also. They are parallel. That means if the vectors are equal and parallel, we can replace one vector by another vector. So we can replace this AV vector. This AV vector can be replaced by DC vector. So here is AD vector minus this is DC vector. Okay. So what can be the region here? This is AD vector equals to, this is AB vector equals to DC vector. Okay. Now 4 number. Now taking dot product of AC and BD. Taking dot product of AC vector and DBD vector. Okay, AC vector and BD vector. Now see what happens here. Here is AC dot BD equals to, this is AC means AD plus DC. Yeah, AC means what? AD plus DC dot, this is BD means what? AD minus DC. Okay. Now see, look at here. This is A plus B, A minus B. So it can be changed as A square minus B square. That is A plus B, A minus B gives A square minus B square. Okay. Now see, in this case AD and DC. AD and DC, their magnitudes are equal. We are already given here AD and DC. So I can replace AD by DC. So DC square minus DC square, they are cancelled, gives 0. So the dot product of two vectors comes 0. That means they are what? Perpendicular. They are what? Perpendicular. Now see, they are perpendicular. Hence the diagonals of rhombus are bisected with each other at 90 degree. Hence proved. Thank you.